In this video here, we're going to take a look at momentum as a vector. Now, as we established in the first video of this chapter here on momentum and impulse, impulse and momentum are both vector quantities. And what we can do then is write the impulse momentum principle and the principle of conservation of momentum as vector equations and use them to solve problems involving collisions where the velocities and any impulse are given in vector form. So, I here is the impulse vector, which is equal to m times v minus m times u. And that should look familiar, right? So m here is the mass of the body, u is the initial velocity, and v is the final velocity. Okay, where u and v here are given as vectors. And what we've also got here then is m1 times u1 plus m2 times u2 is equal to m1 times v1 plus m2 times v2. So what we've got here then is a body of mass m1 moving with velocity u1 that collides with a body of mass m2 moving with a velocity of u2. And v1 and v2 here are the velocities of the bodies after the collision. So I'm hoping it kind of goes without saying here, but just make sure then that you're confident with the content from the previous two videos here, right? If you do struggle with any of the content from the previous two videos, you might find this video here a little bit more challenging. Okay, so just in case then, just go back and watch the previous two videos. Just make sure then that you're confident with that material. But with all of that in mind then, let's just work through a couple of practice questions together here. So let's just make a start then with question 1 here. So as we can see then for question 1 here, we have a particle P of mass 3 kilograms that's moving with this velocity here, and it receives an impulse of 3i plus 4j Newton seconds. Now for this question here then, all we want to do is find the speed of the particle P immediately after the impulse is applied. So to get us started here then, all we need to consider is the impulse momentum principle. So the impulse momentum principle here states then that I is equal to mv minus mu. And in this case here, I, v, and u will all be vectors. Okay? Now we know what I is then. I is 3i plus 4j Newton seconds. I've got 3i plus 4j is equal to, now we don't know what v is, right? Okay, that's the final speed here, which we don't know what it is at this point. So I'm just going to call that v, but we do know what m is. M is 3. We've got 3v minus then mu, so minus 3 lots here of u, which is this velocity here. So I minus 2j there. Okay, like so. So let's just expand out here and simplify. So I've got 3i plus 4j here on the left-hand side, like so, is equal to 3v. So minus 3 times I here is minus 3i, minus 3 then times minus 2j here, that is plus 6j there. So just be careful with your signs, right? Like so. So let's just take everything here. Well, not everything. I want to keep the 3v on the right-hand side, but the minus 3i and the 6j, let's take those over to the other side. So I'm going to add 3i and subtract 6j off both sides here. So 3i plus 3i here, that gives us 6i. Like so. 4j minus 6j here, that gives us minus 2j. Okay. And this here then is equal to 3v. Now clearly all we want here, right, is v, so let's just divide both sides by 3. So therefore in that case then v here is equal to the following. So 6 divided by 3 is 2. So I get 2i there, minus 2 divided by 3. We'll just leave that in its exact form. So minus 2 over 3j there. Okay. So this here then is the final speed, right? V, so that's 2i minus 2 over 3j there. Now, what the question's asking for here is the speed of P immediately after the impulse is applied. So don't forget then, speed is equal to the magnitude of the velocity vector. So speed is equal to the magnitude then of this vector here. So that would be the square root then of 2 squared. So 2 squared plus minus 2 over 3 all squared. So minus 2 over 3 all squared, like so. So just put this into your calculator here. And what you should get then is the square root of 40 over 9. Okay, now we can simplify this and give it an exact form. That's absolutely fine. Alternatively, what we can just do here is give it as a decimal. So I'll give it an exact form first and also just give the equivalent decimal. So I can write this as root 40 over 3, because root 9 is 3, right? Root 40 then, we can write that as 2 root 10. So what I get here then is 2 root 10 over 3. And this here then is for the speed. So my units here are meters per second. Okay. And if I just give the equivalent decimal here, right? So just put any of these here into your calculator. What you get then as a decimal here is 2.1 on there. Okay, so 2.11 meters per second. Okay. And there we have it then. So that gives us the solution there to question 1. So to finish with here then, let's just have a go now at the very last question for this video, question 2. So for question 2 then, we have a ball of mass 0.5 kilograms that's hit by a bat. So immediately before being hit, the velocity of the ball is given as follows. So 12I minus 2j meters per second. And then immediately afterwards, it's given as minus 20I plus 4j meters per second. So for this question here then, all we want to do is find the magnitude of the impulse exerted on the ball by the bat. So for this question here then, don't forget that impulse, I here, and this will be given as a vector, right, given that the velocities here are given as vectors, is equal to the change in momentum. So that's mv minus mu. Okay, so the impulse, right, we don't know what that is. That's what we're looking to find, or the magnitude of the impulse anyway. So I here is equal to, so m for this question here is 0.5. I've got 0.5 times v, that's the final velocity here, which we can take as minus 20i plus 4j. So minus 20i plus 4j, like so. And then minus here, again, 0.5 times u here, which is the initial velocity. So that's 12i minus 2j. So 12i minus 2j there, like so. So let's just evaluate this here then. So I, the impulse here, is equal to the following. So I get minus 10i plus 2j. So minus 10i plus 2j. What else do we get here? So we get minus 6i. So minus 6i, and then minus 0.5 times minus 2j here. That just gives us plus j there. Okay. And then finally, to finish with here, let's just simplify. So I is equal to minus 16i. So minus 16i there. And then 2j plus j here. That gives us plus 3j. Okay. Now the question wants the magnitude of the impulse here. So the magnitude then. So magnitude of the impulse then. So nice and straightforward here then, that is equal to the square root. So we get the square root here then of minus 16 squared. So minus 16 squared plus 3 squared. Okay. So if we evaluate this here then, this gives us the square root. So minus 16 squared is 256. So we get 256 plus 9 here. And that gives us the square root then of 265. Okay. And if we just give this here as a decimal then to 3 significant figures, what we get here then is 16.3 Newton seconds there. Okay. And there we have it then. So that gives the solution here to the very last question, question 2. And that brings us to the end then of this video here on momentum as a vector.